solve 2x cubed minus 19x squared plus 49x minus 20 is less than 0. So this is a pretty nasty inequality, but anytime we're solving a polynomial inequality, we're going to need to factor it. And so we're going to use the tools that we've learned about how to find the zeros of this polynomial, because looking at this would probably, if you can factor this by looking at it, that's pretty amazing. So we're going to go through and use our rational zeros theorem, which says that our zeros are going to be factors of 20 divided by factors of 2. So the factors of 20 are 1, 2, 4, 5, 10, and 20. And we divide by the factors of 2, which are 1 and 2. So each of those things divided by 1, and then each of those things divided by 2. So 2 over 2 is 1, 4 over 2 is 2, 5 over 2 I don't have yet, 10 over 2 is 5, and 20 over 2 is 10. So here's my list of possibilities, and I need to find which of these are the zeros of that polynomial. So I'm going to do that with synthetic division. So I've got my coefficients of my polynomial, and then I'm going to pick something out here to test. And I don't want to spend too much time going through this, so I'm just going to pick a number that I know is going to work. 4 is going to work, so I bring down my 2. 2 times 4 is 8. Negative 19 plus 8 is negative 11. Negative 11 times 4 is negative 44. 49 plus negative 44 is 5. 4 times 5 is 20. And add those and you get 0. So now I have... This gives me a factored form. 4 is a 0, which means x minus 4 is a factor. And then these are the coefficients of what's left, 2x squared minus 11x plus 5. And now I want to see if I can factor this. And this does factor. We have a 2x and an x. And then we're going to have a minus 5 over here and a minus 1 over here. And, oh, you know what? I actually missed my 1 over 2 here. 1 over 2. Make sure I have that there. And this now, I've got my fully factored polynomial. I'm looking for one that's less than 0. So I get my zeros from each of these. I get x equals 4. Which has a multiplicity of 1, and I get x equals 1/2 from this middle one. That has a multiplicity of 1, and x equals 5. That also has a multiplicity of 1. And now I can go ahead and plot those on a number line. I've got 1/2, 4, and 5. And so now I've got 4 different regions, but I can, luckily I can use my techniques to kind of speed up my process. The far right region is determined by the leading coefficient, which is a positive. So the far right here is a positive. And each of these zeros has an odd multiplicity, meaning that the sign is going to change as I cross over. So from positive it changes to negative, from negative it changes to positive, from positive it changes to negative. And I am looking for when my polynomial is strictly less than 0. So that's looking for negatives. So that is from negative infinity up to 1/2. And it's a strict inequality, so we're not going to include any endpoints. And also the interval from 4 to 5.